have 11 in there. So I did stat edit, and now I'm going to do stat calc, one var stats. Okay, there's my first, and then I'm going to scroll down, and here is my second. So, all right, my mean is going to be 98.44. I'm going to kind of color coordinate so you can see where things came from. There's my mean. My median is going to be 98.4. Mean, median. My mode, we've got to do this one by hand. That's the one that appears the most. So if I come up to the top, 90, even though 98 appeared twice and 98.6 appeared 3 times, 98.4 appeared the most. So 98.4 is going to be my mode. So we've done mean, median, and mode. Now we need to do, let me get highlighter. Let's do Q1, and then we can do Q3. So my Q1 is going to be 98.4. My Q3 is going to be 98.6. My minimum is going to be 98. My maximum is going to be 99. My minimum and my maximum are 98 and 99. So my range is going to be high minus low, also known as max minus min. So that's going to be 99 minus 98, or 1. And then my standard deviation I had up here. My standard deviation is my SX. I rounded it to 3 decimal places, and so I did 295. My math lab will tell you what they want you to round it to. We good? All right. I'm not going to work out this one, but this one just had a lot of data. So this one would be a good one. If you're doing this on a test and you have a lot of data and it wants you to find the range of the standard deviation, number 1 standard deviation I would definitely do stat edit, stat calc, one var stats. And since you're in there, it's going to tell you the maximum and the minimum. So that way you don't have to say, are you sure you got the biggest number? Let me look, let me look, let me look. Put them in there, go to the second page, and it's going to give you the highest and the lowest. Okay, I'm not going to work that one out, but the answers are there if you want to go back and look at it. All right, this one is not on the test, but it's in your homework. The only difference between this is they gave you 2 sets of data. They're comparing body mass index for Miss America pageants. So y'all, in the 1920s and 30s, if you look back at old videos, Miss America pageants, Miss America contestants were a little bit chunkier in the 1920s and 1930s. They looked healthier. They were real, that's right. They were not like stick people. So this is saying how much fat did a contestant from the 20s and 30s have compared to today. So we have 2 different sets of data. Now, you can do it one of 2 ways. The way I did it is I did, like for part A, I went into my calculator and I did stat edit, typed in my data, and then I did stat calc and wrote out all those answers. And then I went in and did stat edit, typed in all my data for that, and then did stat calc, and I ran it like 2 separate problems. Since we talked about, you could have done part A here and part B here, and then when you go to do stat calc, you could have changed it from list 1 to list 2 and kind of toggled back and forth between the 2. You with me? But this isn't on your test. This is just you comparing 2 different sets of data. So just to show you, I mean, it's in your homework, but I didn't give you anything. So this is me doing stat edit for the 20s and 30s and stat edit for today. And this is me doing stat calc for both. And it says compare. So the average body mass for back in the day was 20. And the average body mass today was 18. So this is telling me they're skinny. They don't have as much fat today. The average standard deviation was 1.47 then and 1.18 now. So the standard deviation is smaller. Standard deviation is your spread. Think about what deviate means. Deviate means go off the path. So, if I told you that the average of the class on a test was 80, and you made an 80, then your deviation would be 0. You didn't deviate off the path. But if you made an 80, if I told you the average was an 80, and you made an 85, then you deviated on the positive side. You went above. But if I said the average was an 80 and you made a 75, then you deviated this way. So the further you made from the average, the bigger the deviation would be. So standard deviation is how far are you off the path of the class. So this is telling me that it has a lower standard deviation, which means all the girls are all the same skinniness. Here, there's a wider standard deviation, so that means you have some that are skinny and some that are chunkier, and they're like all over the place. We both have 10 pieces of data. Here, in today's, which one's today? This one's today. The smallest girl had a 16 BMI, 16% body fat. Here, the smallest girl had 18% body fat. These are our quartiles, our medians. The chunkiest girl today was a 20. The chunkiest girl back then was a 22. So it just wanted us to compare all the data. That's what we're doing. And that's it. Now this one's doing weather forecasting. Is the same basic way. Two types of data. This is what if a weather forecaster was predicting tomorrow's weather versus what if they were predicting it next week. Which one is more accurate? Tomorrow. We should all know that. Okay. So this is saying he was 2 degrees off, 2 degrees off, no degrees off, no degrees off. 3 degrees below where he should have been. This was 2 degrees above where he should have been. Then here, he's 3 degrees off below, 2 degrees off above, 6 degrees off below, 9 degrees off below. So when you type these in, you would do a -6, a -6, a +2, and you would do it the same way. But like I said, these are not on the test, but it's just comparing two sets of data. All right. Range rule of thumb. This is not as hard as it looks. If you're on a date and your boyfriend says, I wonder what the estimated standard deviation is, and you just don't happen to have your graphing calculator on you. You can estimate the standard deviation really quickly. The estimated standard deviation is your range, high minus low, divided by 4. That's the rule. Take your high minus low and divide it by 4. Don't ask me why it's divided by 4. It always works. Here you go. So, the real standard deviation, if you want to know exact standard deviation, stat calc, stat edit, one of our stats, SX, that's the real. But if you just want to know an approximation, we're going to do high minus low divided by 4. And on your test, you're going to have to do a real standard deviation, and you're going to have to do an approximate standard deviation. The approximate standard deviation is going to say, range rule of thumb, it's going to say, approximate the standard deviation using the range rule of thumb. And on your formula sheet, it even has, let me pull it back up, on your formula sheet, right here, it says, let me make it bigger so you can see it. It says range rule of thumb. Standard deviation is approximately, that's what those little wiggly equal signs are. Range rule of thumb, standard deviation is approximately the range divided by 4. Well, if you look right here, it tells you that the range is the largest minus the smallest. So it's on your formula sheet. So if I come back down, let me go down to a real problem. Let me do, okay, let's look at this one. So if I give you this data, and I say approximate the range rule of thumb, approximate the standard deviation. The approximate standard deviation would be high minus low, and I just picked it out. I said, okay, the highest is 77, the lowest is 49. So high minus low divided by 4. So the approximate standard deviation is going to be 7. If I want to know the exact standard deviation, I'm going to do stat edit, go to the top, clear it out, hit enter, 62, 58, 49, 76, 66, 59, 60, 72, 77, 60, and 63. So I'm going to do stat edit, stat calc, 1var stats. So the exact standard deviation is 8.38. So if you come down, I've worked it out for you. Here's some data. The exact standard deviation is 8.39. The estimated standard deviation is 7. Now, I have some people say, well, those aren't very close. If your data's all over the place, if you have outliers, these aren't going to be very close. If the data is close, these are going to be close. If there's a wide variation, these are not going to be good estimates of each other. If there's a low variation, these are going to be better estimates of each other.
So that's
Estimated standard deviation using the range rule of thumb.
that's not the approximate.
That is the approximate.
Oh, okay.
Yes, this is the estimated or approximate. Yes. Estimated or approximate. Yes. All right, here's another one. I just pulled up the BMI, and it says use the range rule of thumb to get the approximate. So I did high minus low divided by 4. And then I did it for the second one, high minus low divided by 4. So those are the approximates. And then I typed in the data, and I gave you the actual. So I just did 2 more, just to show you the difference between what the approximate is and what the actual is. Yay?
Yeah.
All right. Have we ever heard of percentile? What does percentile mean?
Percentage of the whole.
Okay. When have you ever used the term percentile or heard of the term percentile?
Honestly, like
I'll take my kid to
the
the
relative thing.
Okay, we did the relative thing.
You know, the relative frequency.
Like relative frequency, we did percentile. When you take your kid to the doctor. When you take if you don't have kids, when you just got out of high school and you took the SATs or whatever, and they said, oh, you're in the 98th percentile. Okay? So, real life example, when I took my kid to the doctor, if you ever have kids, you take them to the doctor and they measure their head and they measure their height and they measure their weight and they tell you, oh, they're in this percentile. Now, true life story. I go to the doctor with Madison, and they tell me and my ex-husband, oh, her head is the 60th percentile, her height is the 98th percentile, her weight is the 55th percentile. You know, she's a teeny, newborn baby when they do all these measurements. Well, my ex-husband freaks out because he's thinking of SAT. I'm in the 95th percentile. You want your child to be perfect, so you want your child to be close to the 100th percentile. So he is like upset that his child's head is not. So I have to explain to him, if you're taking a test, you want to be in the 100th percentile, because that means you're smarter. So if you're in the 100th percentile for a test, that means if they put 100 people there, you are the smartest out of 100. Or if you're in the 98th percentile, that means you're smarter than 97 people.
Yep.
Okay? So, with my child being in the 60th percentile,
You were grateful.
I am thankful.
Yep.
Because if she was in the 100th percentile for head, that means she has the biggest head out of 100 babies.
And you would.
And I don't want that. So for her to be in the 60th percentile for head, that means out of 100 babies, 59 babies have little head, smaller heads than her.
Mm-hmm.
Y'all with me? So sometimes you don't want to be in the 100th percentile. So what does 98th percentile for height tell you? Okay, she is 11 and is taller than I am. Yeah, Mac's husband's 6'4". So it tells you that she's super tall. Wait, she's in the 55th percentile. So she's big, she's average, but because she's so tall, she's on the bigger side or the chunkier side because of her height. So you've got to think about what percentile means. Percentile means where are you compared to everybody else? And what I usually say is, I just want to know who's below me. You know? When you're taking a test, you ask around because you want to know who made worse than I did. Okay? So when we do percentile, and that gave us this M&M problem, which was kind of boring. But when you do percentile, you really want to know who's below you over the total times 100, because percent has to do with percentile, has to do with percent, and percent is like that whoop whoop, okay? And the whoop whoop is the times 100. So who is below you over the total times 100? So that is going to equal your percentile. Because you're comparing yourself to everybody else. So we are always wanting to know who is below us, who is less than us, because we're comparing ourselves. Especially when you have a baby. How's my baby compared to everybody else? Who's below me? So what they did is they gave us some problems. And I can totally see myself doing this just because I love math so much. A statistics professor with, not that I have too much time on my hands, but too much time on my hands, they gave us some M&M candies, a bag of 465 M&M candies. Okay? They put the M&M candies in order from the least way to the highest ways. Because you know some M&M candies are chintzy, and then some of them are like a double M&M, which is God's way of thanking me. Yeah. So, one of the M&Ms weighed 0.776 grams, and it was heavier than 25 of the other M&Ms. What is the percentile of that particular M&M? Now, did I tell you how tall Madison was? Did I tell you how big her head was? So, I don't care what that M&M weighed, because I didn't tell you what Madison weighed. I just want to know how many M&Ms are below me. Okay? So my formula is to get your percentile, how many M&Ms are below you. So here's my little picture. This is my smallest M&M, this is my biggest M&M, this is my M&M I'm looking at. This is how much it weighed, but I don't care because I didn't know how much Madison weighed. There's my 465. Okay? So 25 M&Ms were below me. So my formula is how many are below you over the total. So 25 were below me out of 465 times 100. We cool? So we go to our calculator, 25 over 465 and then times 100. The times 100 is for me to do the whoop whoop. Now, even if this was 5.99999, we would still say 5th percentile. If it's 5 point anything, it is in the 5th percentile. So if it's 5.1, 5.7, 5.2, 5.9, it is still the 5th percentile. We don't round. So no matter what that point is, you do not round. So I just mark that out, and I'm gonna put do not round. So here's another boring M&M problem. One of the M&Ms weighed this. There were 322 heavier. It was heavier than 322 of the other M&Ms. So here's my little picture. You had 465. My little M&M, my purple M&M this time, was heavier than 322 of them. So to get the percentile, how many was below me? How many M&Ms were below me? 322. How many total were there? 465, and we got to do our 100. So again, no matter what that was, 69 point whatever, we say that it's in the 69th percentile. Now, how I'm going to do on the test is I'm going to say, if I'm in the 69th percentile, how many people are above me?
30.
Let me make it easier. If I'm in the 75th percentile,
25.
I didn't want to make y'all do math. So, on the test, I'm not even giving you this stuff. On the test, I'm going to say, if I'm in the 75th percentile, how many people are better than me?
25.
So, if I'm in 75th, that means those people are below me. I want to know how many people are better than me. Y'all with me? I want you to understand what percentile means. Percentile means 75 people are below me, so that means 25% of the people are above me. We good?
Yep.
All right. So that is percentile. Look, if you are in the 70th percentile, how many people are smarter than you?
30.
30. Okay, this is kind of like a summary problem. I gave you 4 sets of data, and I said make a histogram. So I have 1, 2, 3, 4, 5, 6 sixes, or 7 sixes. 1, 2, 3, 4, 5, 6, 7. So I went to the sixes and I put 7 on them. I have 2 5s, 3 6s, and 2 7s. So I have 2 5s, 3 6s, and 2 7s. Y'all with me? I have 3 5s, 1 6, 3 7s. 3 5s, 1 6, 3 7s. I have 3 3s, a 6, and 3 9s. So it says first, I want you to make a histogram. Then it says, part B, give the 5-number summary and a box plot. So I took that data, 6, 6, 6, 6, 6, 5, 5, da, da, da. I went to stat edit and I typed in my data. I went to stat edit, I typed in my data. I went to stat edit, I typed in my data. I went to stat edit, I typed in my data. And I did one var stats, one var stats, one var stats, one var stats. And I wanted the 5-number summary. The 5-number summary is that second page of data, not the first page, but the second page. Y'all with me? And it's the last 5 things. That's my 5-number summary. 5-number summary, 5-number summary, 5-number summary. It says, give me the 5-number summary. That's the min, Q1, medium, Q3, and maximum. And draw a box plot. Remember, the 3 on the middle make the box, and the 2 on the outside make your whiskers. So, I gave your 5-number summary in red. The box plot, I came down here, and I used the same number line. Well, y'all, all those numbers were the same. There's my box plot, box and whisker. Here, the 3 in the middle are 5, 6, and 7. Well, 5 to 5, it's like he didn't have any whiskers. You cut them off. Same thing here, 5, 6, and 7. 5 to 5, he didn't have any whiskers. And then I did the same thing here, 9 to 9 and 9 to 9, he didn't have any whiskers. So which one has the highest variation? The last one. Which one has the lowest variation?
The first one. Oh, the first one, sorry.
First.
It has no variation. Everybody made the same score. It has 0 variation. All right, then question C says, compute the standard deviation. What do we call the standard deviation? The SX. So I had already done it up here. The SX is 0, 0.8, 0.9, and 3. See it right there? Based on your results, briefly explain how the standard deviation provides. We just, remember I said the higher the standard deviation, the higher the variation. So this one had low standard deviation and low variation. This one had high standard deviation and high variation. That's all I wrote down. So right here, the higher the standard deviation, the more spread out they are. Therefore, the higher the range, the higher the variation. The lower the deviation, the closer the grades, the smaller the range, the lower the variation. So this is just kind of one problem that gives you a review. This is the same thing. Find the mean, the median, the range, the 5-number summary, the standard deviation, the range rule of thumb. And so I worked out a problem and I gave you all of those things just to review. Now, a couple of things that I want to go back and look at. This is our study guide. Here's some of the things that we did in Chapter 3. If I give you data, make a frequency table. So, right here, if I give you data like red, blue, red, green, red, you should be able to make a frequency table. Y'all with me? If I give you a frequency table, you should be able to find the relative frequencies. So if I give you this, you should be able to pick this. Y'all with me? And y'all, let me, if I get rid of this for a second, this is saying, for number 2, if I give you this, and the question says find relative frequency, and I give you these multiple choice answers.
Yeah.
I'm going to give you a relative and a cumulative. Remember, cumulative is when you do 5, and then you do 5 plus 3, and then you do 5 plus 3 plus 1. That's cumulative. Relative is when you say 5 over 9, 3 over 9, 1 over 9.
Yeah.
And I'm telling you up there that your relative, you're getting a booty call.
Wait a minute, what? Whoa.
Oh,
They call me every Thursday
it's okay.
to make sure I turn in my
Just
Thursday.
go.
They're telling, you didn't get a booty call.
No,
Oh, maybe next time.
spring break's coming.
There you go.
Oh, wait a minute.
All right, decimal. They're telling you that relative is going to be a decimal, so they're telling you that these are going to be in decimal form. Are we good? All right, number 3. Given a frequency table, find the cumulative frequency. The cumulatives are when we did 5, and then 5 plus 3, and then 5 plus 3 plus 1. Then, given a dot plot, answer a question. So I'm going to give you a dot plot, and I'm going to say, how many are in the first 2 columns, or how many are in the first and third column, or how many in the first column. Given a histogram, answer a question. Histograms are when the bars touch. Given a frequency table, construct a Pareto chart. The Pareto chart means they're in order. Given data, construct the stem and leaf plot. These are the ones where I give you data, the stem and remember I said y'all don't make it hard? I have this many 50s. So I'm going to go look at the 50s. Or I may say, okay, y'all, I only have 148. This doesn't have 48. So I can mark him off the list. These have 48s. They both have 62, so let me look at the 50s. Two 52s. This one has two 52s, this one doesn't have two 52s, so it's gonna be that answer. I don't have to write down everything, okay? Then I'm going to go to number 8. Given a stem and leaf plot, answer questions. So if I give you this, I may say who's the oldest, who's the youngest, which decade had the most people. Given a double, and you have two of